The definite integral. The definite integral of the function f of x from a to b is the integral from a to b of f of x dx. We will look at how to evaluate this later. This is equal to the limit of the sum of the areas of the rectangles with area f of x delta x, and we're looking at the limit as delta x tends to 0. So we're doing the sum of rectangle areas f of x delta x, and we're looking at the limit of that sum as delta x tends to 0. And what we can do is write that using the sigma notation here with I equals 1 to n. So what we're saying is that there are n rectangles, and of course as n tends to infinity we get more and more and more rectangles. If f of x is greater than 0, for x between a and b, as shown in the diagram below, well actually up here, so we've got an f of x where the curve is above the x-axis, which is what this means, for all values of x between a and b. The definite integral in this case is equal to the area under the curve. Now let's just examine this, because this is probably the part of this that's most confusing to you at the moment. If we imagine that we have a very thin rectangle just here, much thinner than the one I've drawn, and we say the width of that is delta x, and if this point here is x, then the height of the curve at that point is f of x. Now it's clear that this isn't a rectangle, but if it was really thin it would be approximately a rectangle, and the height would be f of x, and the width delta x, f of x delta x. So that's the area of that rectangle, and if it's really thin we're not cutting off much area. And here what we're doing is tending that delta x to 0 so that it's really thin, so that the rectangle really does cut off virtually 0 area. And then what we have is a sum of all of those rectangles going all the way across, and so that would give us the area. Now I've specified here that f of x is above, in between a and b, because it's more complicated with curves that dip below, like so, and we'll see that as we go through examples and we look at further work on this. We will look at evaluating definite integrals later, but for now, in order to grow our understanding of what's going on with this, we're going to look at evaluating them using more rectangles than in the introductory examples that came before this lesson.